Hey guys, so today we're going to look at part 3 of the Eccentricity Lab. So let's look at the procedure. It says draw and label the major axis of Mars for Mars's orbit. This looks like Mars's orbit. Notice that the sun is one of our foci and we have an imaginary point on the other side, and Mars is going around in its orbit. And I just need to draw the major axis. And remember, the major axis is a line that goes from one side of the circle to the other, and it's going through my foci. So I'm going to use my ruler and I'm just going to create that line like this. And this is my major axis. It wants me to not only draw but label. So I'm going to do an arrow right here and write that this is my major axis. Okay. And then it says place an F on Mars orbit and write fastest next to it to represent the position when Mars's orbital velocity would be fastest. Now it's asking us where Mars in its orbit would be fastest and slowest. And that actually depends on how close it is to the sun. Remember, the sun has a lot of gravity, and the closer you are to something that has a lot of gravity, the faster that planet will move, because the sun's gravitational pull on Mars will help it to move a little faster when it's closer to the sun, and it's actually going to go a little slower when it's farther than the sun. And the point that Mars is closest to the sun is actually right next to the sun in its orbit right here. So wherever the sun isn't in the center, right? It's kind of on either one foci or the other. Whichever side the sun is on, that is the side that Mars will be fastest in its orbit. So this is where Mars would be fastest, and I'm gonna write F right next to it. You can draw an X or a dot. Here's F, and F means fastest. Okay, now number 3 says place an S on Mars's orbit and write the word slowest to represent the position when Mars's orbital velocity would be slowest. So Mars's orbital velocity would actually be slowest away from the sun, where it's farthest from the sun. Notice that the sun is not in the center, it's kind of towards the side, towards the left side, right? So which means Mars would actually be slowest on this part of its orbit when it's farthest away from the sun versus closest to the sun. So I'm going to draw an X right here and write S for slowest. Okay, and once again, it depends on the gravitational pull of the sun. Wherever it's closest, the sun will help it move around a bit faster. So go ahead and try this question number 1 here. You're finding the distance between foci, again, in centimeters to the nearest tenth. You're finding the length of major axis from here to the nearest tenth. And then you're finding the eccentricity. You're calculating the eccentricity. Make sure you show all your work on the side over here. Remember, eccentricity has no units. Next, you're going to be answering these questions based on your calculations. And that's it. Thank you.